Hi everyone, my name is Lee France. I'm a cartographer for Gaia GPS and I'm based in Sandpoint, Idaho.
And I'm John Czaplewski. I am a software engineer at Gaia GPS, and I'm based in Minneapolis, Minnesota.
We're here today to present symbol groups and how we built them for our global vector-based outdoor recreation base map, Gaia Topo. This presentation is pre-recorded and we have a lot of great info to get through. So if you have any questions, please drop them in the comments section and we'll do our best to answer throughout the presentation. Now, what are symbol groups and why use them on maps? They're a fairly common feature on outdoor recreation-based paper maps, and what they essentially are point clusters representing concentrations of relevant amenities, typically relating to outdoor recreation. They're a way to cluster points in dense areas, but still display the individual relevant icons. For paper maps, this has allowed us to depict important map information at smaller scales. So why should we use them on a vector-based slippy map? Arguably, one could just zoom deeper into the map to find the individual point locations. This is true, but that often requires a person to know just where to look. By implementing the same cartographic style in a slippy map, we help facilitate discovery. The map may reveal a more developed recreation area that is rich in different important amenities such as refuel or resupply options. So how do we go about achieving these symbol groups on a global scale in a vector tiled slippy map? We can't just place symbols in a nice grid manually. There has to be a way to automate it. We wanted to keep our cartographic limitations to what is possible with Mapbox styling syntax, and we want the symbol groups to be built into our vector tiles. Finally, it had to be fast enough computationally that we could update the globe on a weekly basis. Up until this point, our workflow had consisted of rendering symbols in Mapbox.gl as sprites, which are little PNG images that are extracted from a larger sprite sheet containing all of the symbols. Now, we know we can place labels for points in Mapbox styling by creating a symbol layer and assigning a sprite to the symbol, and usually using a name field or some other relevant field as a label to go with the symbol. But what if the label also contained the symbol itself? This would require us to, instead of using sprites, to use a font to represent our symbols. This was a concept that was new to me, so I went to work researching the idea, and sure enough, creating a font out of symbols is very possible. I came across a lot of great options for creating a custom font, and I've listed a few of them here. Some are simple, some are more robust and had a bit more of a learning curve. Some cost some money and some are free. I came across this great guide by Brian Suda titled Creating Symbol Fonts, and I found that to be an extremely valuable resource throughout this process. One thing they all seem to have in common was that you want your icons in a nice SVG format. The edges needed to be snapped to a grid so that they can scale up and down easily without getting any fuzzy edges. And you can't have shapes on top of shapes. They have to all be single paths or compound paths. So once the symbols are in a nice SVG format, how do we get from there to a font? We ended up using the iCommun app for various reasons, but mainly it was a pretty intuitive and easy workflow that didn't require too much of a learning curve or a financial investment to build a custom font. It also generated the true type font file that we needed to build glyphs from the font. I wanted to go over a little bit of the workflow using iCommun since it's so nice and easy. To get started, you simply just need to upload your set of SVG icons. An important detail, I discovered that once your icons are uploaded, you want them to all be set to a constant grid size, even though you probably did that during your SVG creation earlier. There is an option to go into the properties of the symbol and reset the grid. I ended up using a size of 16. Then simply select the generate font option to build your new custom font. At this point, you could dive into the details of each icon, replace icons with another, and the most important part, download the true type font file. You can also download a JSON of your project from iCommun, which, as I later discovered, is a great way to restore your project if something goes awry or you need to make changes to your font down the road. You could also pay a very reasonable yearly subscription, and iCommun will save your projects. Now, in order to use our new font in the map, it needs to be converted to a set of glyphs. There are some great open source options available for creating custom glyphs. We use font glyphs here at Gaia. So now, how do we form a bridge from our point data to our new symbol font? There are probably a few creative ways to go about this, but this was the method that I found and ended up implementing. The font contains a special character for each symbol, which you can get by downloading the project JSON from iCommun. So what I ended up doing was I built a table containing all the different POI types in our point data in one column and the corresponding special character in the other column. Then we could just import this table into Postgres and join it to our table of point data. So now we have hard-coded that special character in the map tiles for the point data we want to render as a symbol. Finally, we get to the fun part, the cartographic styling of our new points on the map. We simply create a symbol layer in our style sheet and label it using our new custom font, which exists in our glyph set. This project coincided perfectly timing-wise with the release of format expressions on the text field from Mapbox. This allows us to label a point with a name and a symbol by giving us the ability to label with 2 different fields and 2 different fonts within the same layer of the style sheet. There are some other great advantages to a symbol font, such as the ability to change the color of the symbols without needing different versions of the symbol in a sprite sheet. You can also shrink and expand the symbol and get perfect smooth edges and no pixelation, as long as the edges were kept to the nice grid when the SVGs were first built. Also, a small sort of cartographic side note that I pointed out here on the slide. Since the symbols have to be flat single paths, what if you want some kind of a fill for the white space inside the symbol? Thankfully, the halo property can handle that. In this example, I applied a 2-pixel halo to the font, and that acts like a fill for the symbol as it reads those inner details as actual edges of the font. Well, we finally arrived at font-based symbols on our map. But our presentation wasn't just about how to build a symbol font, it was how to create these nice symbol groups. So I'll turn it over to John now to discuss the magic he helped build behind the scenes to get these nice symbol groups in our map.
So we start the process of creating POI clusters by considering only certain types of POIs and only those that are within parks or natural areas. This is done for both cartographic and computing reasons. We want to ensure that the symbol groups display relevant, scale-appropriate data at each zoom level and don't appear cluttered. We also want to display or push our visual hierarchy towards parks and natural areas to encourage users to explore those areas. Additionally, by only considering parks and natural areas, this significantly speeds up our processing time and allows us to run this as part of our weekly global OSM update, meaning any updates to POIs within OSM will be reflected within these symbol groups in no more than 7 days. In this made-up example, we start with all of our target POIs for a given zoom level. For the sake of clarity, I did not include all POIs at the density that they would actually exist because it would be difficult to see. But as you can see, there are a couple areas that seem to have a pretty natural clustering of POIs. The next step is to compute the clusters. This is done within PostGIS using the stclusterdbscan function. In contrast to some other clustering algorithms such as k-means, the number of features per cluster does not need to be known a priori. Instead, we are able to parameterize the function with the minimum number of features per cluster, as well as a distance threshold for each cluster. We tweak that last parameter per zoom level, so clusters at zoom 9 will draw from a larger spatial extent than those at, say, zoom 12. As you can see, points that do not meet these search criteria are discarded. From this result, we assign a unique cluster ID to each POI in that cluster. In the next step, we create a geometry and a list of unique POIs for that cluster. For this step, the cluster did not have a geometry, or prior to this step, the cluster did not have a geometry. So to create one that can be used to place it on the map, we get the centroid of the envelope of all POIs in that cluster. We also find all unique symbols associated with POIs in this cluster, filter out the duplicates, and order them for consistency once they're displayed on the map. Finally, we create a sensible label for the cluster and format the icons so that they're always drawn in rows of 3. To choose the label, we query various nearby features, rank the results, and choose the best fit. For example, for zoom 9, we check if there are any nearby towns, ski areas, small populated places, or water features that meet certain criteria, or parks. For each of those categories, we select 1 or 0 items, and from that list, choose the best. At larger scales, this will include things like trailheads, campsites, beaches, and mountain passes. In order to produce higher quality results, for many categories, we only query features that have a Wikidata or Wikipedia tag in OSM to ensure that we're using names that contain some reference. If you look at Gaia Topo today, you may come across a few oddly named clusters. In those cases, it is usually a campsite from OSM that someone imported from a trip. But generally speaking, this method produces very high quality results. This process is then repeated for zoom levels 9 to 13, and the data becomes part of our global vector tiles. You can view these symbols in action by going to GaiaGPS.com/map or by downloading Gaia GPS from the App Store of your choice. We hope this gave you all an idea of how techniques from the print world can be brought to the digital and scaled globally. If you have any questions, please feel free to tweet us to continue the conversation. Thank you.
Thank you so much, John and Lee, for that fantastic talk. I have a few questions and we'll have time to answer them, hopefully. If not, obviously, everyone can continue the discussion on our Slack. But first, I want to ask, I always joke that with web mapping, kind of the end goal, no matter what happens, is that you do eventually come to the consideration of making something a paper map again. And so I wonder if there's any consideration to make this map now printable and do direct paper comparisons with the traditional or typical topo maps that you took a lot of these tips from, or whether you just want to keep it mobile.
I mean, I came from a background of paper maps before I started working here at Gaia, so I think a lot of the design ideas that I try to implement here are with that sort of origination in mind. So yeah, I mean, we do have a print feature for our website, and I think that is definitely a consideration while we're designing these things. Is it would be great if they could look great in a print medium as well.
Great. And then for John, from a technological point of view, how much have you had to really assist Lee on some of these tips around symbology or halo hacking to make sure that we're able to add these principles from print maps into modern web mapping solutions?
In terms of some of those more front-end hacks that he's had to do, I didn't have much of a role in that. I more played a role in the data processing side of things to make sure that we could actually process this data quickly and efficiently so that he could symbolize it properly.
And were there any data processing concerns that you ran into, or some that you might want to document for general data nerds in this field as well?
I wouldn't say there's anything in particular, but I would say that this was definitely a trial and error sort of process, especially in terms of label ranking. We came up with some basic rules that we wanted to start with of which order we wanted to apply labels to clusters in. And that was only something we were able to refine after a couple iterations, going through, seeing what it looks like in different places in the world, and really getting a sense of what kind of ranking we want to apply. So there is an aspect of this that it's really hard to know beforehand what you want to do until you actually have something in front of you that you can look at and visualize.
Makes total sense. Well, thank you both so much again. It was a great talk. And if anyone has any further questions, yet again, may you go over to the Slack, or I'm sure you can contact them over email or Twitter.